Paper chromatography is a technique used to separate low molecular weight compounds based on their distribution between stationary and mobile phases. Due to the low cost and availability of various protocols for compound isolation, paper chromatography is considered a powerful analytical tool. For this experiment, we need the following: 2 to 5 pieces of fresh green leaves, some fine sand, chromatography paper, solvent, in which I use the ethyl alcohol, chromatography glass with lid, pencil and scale ruler, scissor and thread, vial or the small glass, bowl and spatula since I don't have pestle and mortar. To begin the experiment, take 2 to 5 fresh green leaves. Discard the midrip. And grind the rest in a small amount of ethyl alcohol solvent along with some fine sand to aid in the grinding process. Add more solvent if required. Filter the extract and collect the supernatant in a small container. Keep this extract aside and proceed with preparing the chromatography paper and the chamber. Take a strip of filter paper and pre-cut to approximately 5 by 20 centimeters. Draw a pencil line above 1 centimeter line above one end of the paper. Meanwhile, take the chromatography glass and stretch a thread across the diameter of the mouth of the glass and secure with Scotch tape. Now, take the chromatography paper and using a fine capillary tube, apply microdroplets of the leaf extract at the center of the pencil line. But since we don't have a fine capillary tube at home, I used the pointed part of the scissor instead. Allow the first spot to air dry and then take another drop and air dry again. Repeat the application for 5 to 10 times. Now, make a fold on the other end of the paper. Carefully lower the paper into the glass with the solvent inside and use the fold to hang the paper on the thread. Cover the glass and allow the solvent to rise to the paper. As the solvent runs, you will observe the leaf extract that was previously applied onto the paper starts to travel upwards along with the solvent. And as it travels, it gets separated between its constituent pigments. Remove the paper from the glass when the solvent and the leaf extract stop moving and arrive at a certain distance. Immediately mark the solvent front using the pencil and allow the paper to air dry. Mark the farthest distance traveled by each pigment on the paper. The green leaves used in this experiment found to have 3 pigments, namely chlorophyll B, xanthophyll, and carotene. Using a scale, measure the distance traveled by each pigment and calculate the RF value for each pigment using the formula RF equals distance traveled by pigment divided by distance traveled by solvent.